So there's another video of this problem, but it uses what Mr. Hubley called big number logic. However, the answer key uses algebra to do it more rigorously. And the algebra process looks like this. And this explanation should, I think, make more sense than what you see in the answer key. We currently have an infinity over infinity indeterminate form. If we multiply by 1 over x on the top and the bottom, look at what happens to the denominator. 6x will become 6 minus this will become 1 over x. And as x approaches infinity, 6 minus 1 over x will approach 6 minus 0, or just 6. So that's the first step. And what will happen in the numerator? Well, in the numerator, how could we represent this exact same value with a square root sign? And we're asking that question because when you multiply a square root times a square root, you can multiply the expressions on the square roots. Well, this is equivalent to the square root of 1 over x squared. So the square root of 1 over x squared is exactly the same thing as 1 over x. Now we can multiply the insides, and what do we get? 1 over x squared times 16x squared is just 16. And 1 over x squared times 5 is 5 over x squared. And now you can see that as x approaches infinity, the denominator approaches 6 minus 0, and the numerator approaches 16 minus 5 over infinity, or 16 minus 0, or the square root of 16, which is 4. And that's how we get the answer with a very rigorous approach. Not big number logic, which I like, don't get me wrong, but this was the rigorous approach.